Hi, I'm going to walk you through looking at some data, just a little, I don't know if it's a hint, but just to show you what it's like to work with real data. So I'm getting data from uh, a buoy or buoy called H1, and it's provided by something called Smart Atlantic. So H1 is outside Halifax Harbour in Nova Scotia. I'm using the package the package called Dodd, which you can get from doing this line here, line 2. Um, it's in kind of continual development. It basically makes it a little easier for you to download oceanographic data. You don't have to remember URLs and how to use them. Okay, so what I'm going to do is I'm going to run some lines here. I'm in an editor. The top part of this window is an editor. The bottom part is an R session. So if I'll run the first line and the second and the third. So what boy has done, or buoy if you want to say it that way, it's downloaded some data. It already has the data. What I'm saying, the age parameter says if you've downloaded the data in the last 30 days, don't bother downloading it again. That's what that means. I'll set window is true. You'll see what that means in a little while. Now what I'm going to do is I'm going to read the data. So the way the data look is that the first line holds the names of columns. The second line holds the units, and then all the lines below hold the data. So I'm extracting in line 8 here, I'm extracting the column names. Actually, you can see them. Um, sorry, those are the column names. Now what I'm going to do is to read the data. So notice the skip is 2, so I'm skipping the 2 header lines. And now I'm constructing a time. And I've looked at the data. I'll just say, you can see there, I'm looking at the first few lines of the data, so you can see the format that it's year dash month dash day, T, capital T. And then the time, 19, this is 1900 hours, UTC, Z means UTC, Z means UTC. So that's what I'm doing here. This is saying year, month, day, and then capital T, hour, minute, a second, and then Z, which is just recognized there. And I'm putting the time zone of UTC. So that's what I'm doing there. So now there's a time column in that as well. I'm going to window the data, and I've set window is true up above here. So what that just did was I'm looking at the first month, January of the present year, 2024. This is for another purpose, actually. I guess I won't tell you what the other purpose is. Um, I'm going to say that I want to have 3 panels arranged in the vertical. I'm defining here a function which I'm calling H. I'm not, yeah, I should probably have cut this out for this video, but I'm going to keep it anyways. What that's doing is it's going to draw 3 sort of like highlighting lines, and the color here is kind of a yellow, and the 50 means it has an alpha. It's a semi-transparent, and you're going to see it in just yeah, you'll see it in just a second. Okay. Now what I do is I plot the time and the significant HT sig. That's the significant wave height. And if I pop over to the other window, you can see that. That's a graph of significant wave height. And this is in year 2024. So there must have been, so there are big waves here and here and here. And I would say there's a storm is what I think has caused those waves. And I guess I'll call the H4, the H thing, just so you can sort of see what it does. See, it's just highlighting some things, that's all. I don't really need that. So maybe, in fact, for this purpose, I'll just remove it. Oh, sorry. Where are we at here? It's a video. You can stop and go back if you want. Okay, so that's good. I'm grabbing the limit. I don't actually need to do that here, but my real purpose was to compare it to meteorological data, but I'm not going to show that to you now. Okay, now what I'm going to do is I'm going to show you, this is the sea surface wave mean period. That's the mean period of waves. So there we go. Now there's some funny things in here. So it's like a crazy spike. Looks like it's 1 data point and maybe 1 data point here. It's a little bit hard to measure this. And no, it's hard to measure it. When there are big waves, the period tends to go up a little bit. This is the mean wave period though, actually. If I were to have plotted the the highest wave period, you'd get, I think, crazy results. I don't think the instrument's working very well. But there's something weird here. You probably noticed it while I've been yammering here. I can't quite notice it in this one, but in this one, it's like retracing. Time is clearly not monotonic here. So it has to be retracing its steps, which is very strange. So now what I've done is I've made, I'm calling it dot, which is the difference of the order of the times. And in line 36, that's what I'm computing. In line 37, I'm making it have the same length as the time so that I can run a plot. And so here's the plot. And when this number is equal to, when this thing is equal to, okay, here the times are uniform. That's what I'm trying to say. They're uniform here. Now they're not uniform. This is in the difference of the order. So they're jumping, and it's about once an hour is the sampling rate. So they're jumping back and forth in time, positive and negative in time. Completely weird, actually. So, I mean, how could I learn more about that? Well, I could just do this. Sorry, I could do that. Maybe I don't trust that I did the thing quite right, so I'll do what's that? Boolean time stamp, and then t is equal to, that's probably good. Right. That allows me, because maybe I read the times wrong. Maybe that's what I've done. So I'll look over here and you can see it's hour 1, hour 2, hour 15, same day, and then hour 18. And then the next day, hour 0 and hour 16. Something is odd here. And I probably should say that we should check back and forth between the two columns. And I mean, you've done that by now, and it's read the times correctly. Yeah, so something strange there. I'll comment that line out. And now I'm going to turn the windowing off. And that's now going to let us see the entire data set. And I'm running the whole file. And there we go. There's the whole file. So previous to this, I was showing you just the first month of 2024. From here on to the right. And that's the kind of wacky times. But there's wacky times all over the place. The other thing is, I would just say, I don't trust this. I don't know what's going on. So at this point, it was obviously taken out of the water for refurbishing or something like that. And it looks to me like it was giving, I'm just going to say, not good data in here. The significant wave height is just bubbling around 0 meters, like a few centimeters. Makes no sense at all. So there's just something wrong. And I suspect what they did was maybe someone noticed this problem and contacted somebody else, and this ended before January. But it looks like it was early weeks or so of January when somebody maybe took it back to the bench and worked on it or something. Um, so it seems to have settled down before that, but gosh, I don't know. I mean, there's no logbook in this, really. There's no way for me to know uh, what had happened. Don't even know who I would contact. Like, I don't, somebody must own it. I guess some company does own it. I'm not really very interested in contacting them and asking their technician to spend time looking through their notebooks and see, oh yeah, we took the truck and drove out and picked it up on this day. We rented, a boat from so and so, and then we went out and got it, brought it back, and ordered a new part, and on and on and on. What is the point of this video? Look at your data carefully. Just that's the point. Look at your data carefully. Don't just look in the little window that you're interested in for your particular scientific purpose, which was what I was showing you first, that first picture, which I can actually retrieve. I was really interested in this thing, this time period. So don't just do that. Look at the whole data probably and just try to figure out, are there any weirdnesses? Some weirdnesses will be individual spikes, which you might not believe. I don't believe this period that went down all the way to, it looks like 0. I guess it went down to 0. I mean, there's something funny there. This clearly is a completely different character than this region in here, completely different character. And you can see that in both the period and the significant wave height. Unlike other fields, you can't go back in time. Do you know what I mean? You can repeat an experiment that you did on the lab bench. You can't, these are the data. These are the data we have. There's other buoys within like a 20-kilometer range, but these are the data we have at this spot. Obviously, the waves are different at different spots. They're coming in and refracting as they get into the harbor and so forth. This is it. This is what you've got to deal with. There's no guidebook to tell you exactly what to do. And you certainly can't go back and redo the experiment. That's the end of the video. Thanks for watching. Bye.